So. Next, this goes my chalk. Okay, so we pose the problem, height of a ball is given by this expression. What will the height be, or at what time or times will the height be 40? All right. Well, first thing you have to do is use the information to write an equation. Now, everybody wrote down the quadratic formula. Okay. That's good. You're kind of putting the cart before the horse because you don't know yet if you have a quadratic equation, but you kind of know that you do because you had homework. It's a quadratic equation. Okay. And if you know the formula, that's really good. Okay. All you need to do is write the equation, put it into the right form and apply the formula and you're done. Okay. So you've got 2/3 of it. But the important third is you got to write the equation. Okay. Now, the logic of writing the equation is the height is this expression. Also, if the height's 40, then -5t squared plus 30t plus 10 equals 40. Make sense? So you have to understand that that's what this information is telling you. For this, if you want to use this information, you use the height function and you set it equal to what the height is that you're looking for. Okay. So now all we have to do is solve. Now, the quadratic formula, everybody thinks the quadratic formula is just x equals -b plus or minus the square root of b squared minus 4ac, all that divided by 2a. Okay. That's not the quadratic formula. That's part of the quadratic formula. The quadratic formula includes the statement about what it means. Okay. So really, you need to put this statement, this full statement into your head. Okay, so. Okay, and the importance of this statement is it tells you what the quadratic formula applies to. Because the next thing I usually see at this stage of the learning process is people will plug in -5, 30, and 10 for A, B, and C. And that's, you know something if you do that, ignoring the fact that you have to have a quadratic expression that's equal to 0. And you don't have equal to 0 up here. Okay. So, I mean, if you just want to remember this works as long as you got 0 on the other side, okay. You don't necessarily have to remember every word. I kind of like wording. And it's got a little bit of mathematical sophistication to it. It would be to your advantage to know those words and think about what they mean. But if you just remember, okay, we can't apply it here. It doesn't apply. Okay. Doesn't apply because this isn't zero. Put it in sophisticated mathematical language, ain't zero. Okay, it's got to be zero. Now, it doesn't mean you just throw it away and make it zero. Here's your equation. You got to have an equivalent equation. Equivalent equation is negative 5t squared plus 30t minus 30 equals 0. And how did we get that? We subtracted 40 from both sides. Okay. I got that written in tiny letters, which says subtract 40 both sides and you get this. Okay. Should be obvious. If you want a 0 here, you're going to have to subtract a 40. And you can't subtract a 40 on this side without subtracting a 40 on this side, unless you want to get an equation that's not equivalent. So equivalent means solutions of this equation are identical to the solutions to this equation. Okay. So what we do is we write our equation. And we, try to get yourself to write out the words that say exactly what you're doing and why you're doing it. Doesn't take that long. It reinforces it so you don't forget to do it. Okay. Logic is height is this. If the height is 40, then this equals 40. We're going to write that out. Now you solve this. And after you've solved a few of them, gotten the wrong answers, you get used to, you got to get 0 on one side and using valid procedures. You're going to get feedback. You're not getting the right solution. Okay. Okay, well, there we have it. So now we just solve the equation. And that's really easy. Okay, now the formula applies. Okay, so again, we have that's not x, it's t, and it doesn't matter whether that's x, t, aardvark, or anything else. Okay, whatever your variable is, this is going to work for that variable. And we write this down, negative 5t squared plus 30t minus 30 equals 0. And we write that, okay, A is negative 5, B is 30, C is negative 30. So your solutions are T equals negative B plus or minus the square root of B squared minus 4AC all divided by 2A. And that's going to be negative 30 plus or minus the square root of 30 squared minus 4 times negative 5 times negative 30. All that divided by 2 times negative 5. Just plug in my A, B, and C in. Okay, well, that then is negative 30. Okay, 30 squared is 900. 4 times 5 times 30 is 600. And that's going to be 30 squared minus, well, that's minus a positive number, so it's going to be minus. So this is going to come out 300 over -10. And you can do that arithmetic. As soon as you got the numbers in there, you're pretty well home free. So this is approximately -30 plus or minus the square root of 17. It's now 17.5. 17 squared is 289. 18 squared is 324. It's going to make this about 17.6. And that's wrong. It's more like 17.4. Might even be some, it's probably 17.3 something. And probably rounds off to 4, but maybe rounds off to 3. Okay. Your calculator will tell you. So it's this. And it's not the square root of 17.4. Square root of 300 is 17.4. I was busy making the approximation and threw down a square root sign there that I shouldn't have. Okay, well, there we have it. Now, that means we have either -30 plus 17.4 over 10 or -30 minus 17.4 over 10. And we add those. -30 and 17.4 is -12.6. And you divide that by -10, you get 1.26. And here, -30 minus 17.4 is -47.4. You divide that by -10, you get 4.74. Okay. And why do you get two solutions? Well, if I toss this up in the air, when is it this high? Going up and coming down, right? Going up, it passes this point, coming down, it passes this point. Okay. So there are two solutions. Now there could be no solutions. Look here. I can toss this thing up and it never gets there. Put this too high. All right. So if I put too big of a number in here, my number is 100. What's that going to do in the equation? It's going to make this number here 4 times -5 times -100. Okay, well, that'd be -2000. 30 squared is 900. 900 minus 2000 is a negative number, -1100. So if I make this too high, I'm going to get a negative under here. And there's no real number. It's the square root of a negative. Okay, so make this too high. I'm not going to get there. Or make this number too low. This number actually stands for how fast I toss it, how fast it's going when I toss it up. And we're not going to get into physics of it, but that's interesting. But we're not going to go that deep. Okay. And it's also possible that you only get one solution. If I put this at just the right height, it'll go up to here and stop, come back down. It'll reach this point, but it won't pass it. Okay. So if this number here turns out to be if this number here turns out to be 0, okay, then we're going to have -30 plus or minus 0 over -10. Okay, and this is going to be -3. How about +3? All right, now there's much more to it, and we're going to talk about it, and we might leave this example up here so we can talk about it. Little debate here. So I want to jump into that because that's what we're doing next. All right, anyhow, with the problems you have on this homework, most of it comes down to just doing this. If you understand this, if you understand the problem, you're going to be able to write out an equation. Once you've written out an equation, you just solve the blank thing. But make sure you use a quadratic formula correctly. First of all, make sure that the equation is in this form with a 0 over here. Then I think you're okay with identifying A, B, and C. Right? So what I saw in the class is nobody wrote an equation. Some people actually got this equation without ever writing out that equation. Okay? At least you're substituting the numbers that you would get from this equation. So somehow somebody skipped from there to here, but did it without doing the intermediate steps that tie together your understanding of the situation so you can get the right solution. Okay. So I strongly recommend that you write out your solutions like this. Now you might skip some of this. If you just go from this to this equation, you're kind of okay. But you want to think about why that works, okay? You want to think about exactly what the quadratic formula says. The bottom line is it applies to an equation like this with an equal 0, okay? So if you have this equation and know that you got to get 0 there, then it's a pretty simple matter. You just plug into the quadratic form. All right. Okay, well, I'm going to take just a quick look here and make sure I'm doing the right thing for you. Okay, now one student started off the solution to this problem we just did and started drawing a graph. And I just said this in a little more detail and so forth, but that was a good instinct. But how are you going to draw a graph of this function? Okay. You don't know where it is. Remember that this function can be built up from your basic squaring function. It's a parabola. Okay. But it's been shifted and stretched and actually reflected because you got a negative here in front of the t squared. Okay. You don't know where it's going to be. So it's pointless to start drawing a graph and putting a scale on it when, for all you know, that thing is going to be out there 100 units this way and 300 units that way and upside down. Okay. Now it's kind of like that, but it's not that far. I'm not going to tell you how far. Okay. So okay, it says its vertex when x equals negative b over 2a. Now, how are you going to remember that? Well, you've got the quadratic formula, right? There it is. Okay. You've also got the quadratic formula, and you can find out when this thing is 0. Okay, it has vertex here. And let me repeat, it's really good that everybody wrote down the quadratic formula and do it, okay? It's very good. Shows me that there's hope for some of you. Okay, so. There's hope for all of you, believe me. Okay. And okay, now you tell me, what's the y-intercept? Okay, so I asked what it is, and someone told me C. Okay, it's okay. Well, how did you figure that out? I just remembered it because I did it last night, and that's very good because you did something last night and you actually remembered it. Okay, and it makes me even more optimistic. But then, in general, I asked, "What do you know about the y-intercept?" You got the answer. Same person. You know, well, it happens when x equals 0. So, okay. Now, what do you get when x equals 0? You get 0 here, you get 0 here, and you get C. So that's why the y-intercept is C, right? Okay, so you don't want to remember. I mean, it's okay to remember that the y-intercept is C for a quadratic function. That's not going to help you with a function that isn't quadratic. Okay, you want to go back to the general principle and reinforce that for yourself too. And of course, you knew the general principle. So the general principle is y-intercept happens on the y-axis, and that's where x equals 0. Okay, so the y-intercept occurs at y equals C. Point is 0, C. Okay. So since it's gives me a graph, and this sketch a set of coordinate axes, but don't put a scale on it because you still don't know what the scale is going to be. And then calculate x equals negative b over 2a, and put a point on the y-axis that represents 0, C. Now let's put the information you have on the graph. The information you get from this and this. All right, here's your graph for this function. And I wasn't clear which function we were using. Some people used this function, and that was fine, and did that right. But it's easy to modify it for this function because the only thing that changes, you still have the same b, it's 30, so you still get x equals negative 30 over 2 times negative 5, which is 3. Okay, but your y-intercept is going to go up to 10. Okay, well, I'm going to do this. I'm going to say, okay, here is my x-intercept. This is x equals 3. Now, what I really want is x equals negative b over 2a is a value of x. Okay, and I said it's an x-intercept. It's not an x-intercept. I was thinking about intercepts, and I used the word that was not correct. But x equals negative b over 2a is a line. It's a vertical line. Because it consists of all the points where x equals negative b over 2a. So x equals 3. So this is the line x equals 3. And that line's important because the vertex of this parabola is going to lie on that line. Okay. I said draw a point for y equals c. You could have drawn just about any point. Okay. As long as it's above the axis. Actually better if you figure out where the vertex of the parabola is going to be. Is it down here? Is it up here? Okay. Now I'm going to go ahead and put C here. Okay. Now what we want to do is we want to find the y coordinate of the vertex. Okay. Which means we're going to plug x equals 3 into our function. Because x at the vertex is 3. We just want to find y. And this is actually f of t. So let me change my x's here to t's. Okay, so this is a function of time, so we're going to use t for the variable. But instead of x equals negative b over 2a, you know it's going to be t equals negative b over 2a. Okay. Now, forget all that. There's going to be a point on the graph that corresponds to t equals 3. What's the y value for t equals 3? Figure that out. Y value for t equals 3. Okay, well, not everybody's understanding what the y value for t equals 3 ought to be, but remember that it would have been good. I tell you to write things out clearly and completely. But it would have been helpful if I'd have written out if y equals f of t equals this. Well, now, here's our function. This is what we're analyzing. It's this function we're wanting to graph. Okay. So I'm going to even write on my graph and recommend you do this too. Y equals f of t equals negative 5t plus 5t squared plus 30t plus 10. Kind of a heading on my graph. That reminds me, anytime I need reminding, what it is we're doing, because it's real easy to get caught up in the arithmetic of the calculations and forget what our goal is. Okay, so if I can do a graph and label it like this, or put this right at the top of my page, then I'll always have a point of orientation. Okay, I'll always know where I am, or at least be able to trace back where I am with respect to that function. Okay. So anyhow, the y value for t equals 3 is if t equals 3, and this is f of t equals this, it's f of 3. And of course, f of 3 means replace t by 3. And of course, we probably already knew that. Minus 5 times 3 squared plus 30 times 3 plus 10, and that's negative 15. Sorry, negative 45. Okay, and that's 90, which gives me 45, and I add 10, and I get 55. So now I can put that y value on the graph. Okay. So I'm going to put 55 someplace on this line. Now, if I've already written out my y-intercept, well, that's 10, so 55 is going to be up maybe about here. Okay, this is the point. $3.55. Now, on your own graph, you know, locate that point. If this is 10, that's going to have to be a little over 5 times as far from the x-axis. And sketch me a parabola. You know what the shape of the squaring function is. But the parabola has to go through this point and this point, which means, well, this point's going to be the vertex. This is going to be the high point. It's going to be the extreme point. It's going to be where 0, 0 goes. So your parabola is going to be upside down. It's going to come up here, peak here, and come back down. So sketch me a parabola. Okay, now I'm not recommending that anybody try to make a living as an artist drawing parabolas. Okay. And I wouldn't try to make a living at that either, even though I understand parabolas pretty well. Okay. You know, okay. But you have to understand that, okay, if the vertex is here, then this is the axis of symmetry, and that's just like the y-axis. So you imagine taking your basic parabola, and everybody knows what that's shaped like. You saw what they say that that's not very good either. It's not symmetric, is it? It's really kind of a bad attempt at a parabola, but I didn't give myself any reference points. Okay. As soon as I started here, I should have said, well, it's going to be symmetric. I've got to go an equal distance on the other side. I got to go through that point. So maybe that still sucks. Okay. I wasn't intentionally trying to make a bad parabola to make you feel good. I just made one that's about as bad as everybody else's. Okay, well, the point is now, if I turn that upside down, what's it look like? Well, if I turn that upside down, it's going to look something like this. Is it right? Yeah. Okay, that's a better parabola. Okay, so I love that one. Yeah. Although that won't naturally shape itself as a parabola, it's still pretty good. Okay, so now I go through this point and this point, then I want to be symmetric, right? So I come up here and come through here and come down here. That's symmetric. Well, I kind of missed this point, so it's not a great approximation. Okay, and it's not all that symmetric, but this point ought to be as far on this side of the axis of symmetry as this point is on this side. So it should be here, here. It should have been through maybe here. I didn't miss it by much. Okay, but you see every point here ought to be a reflection of the point on the other side. So you want to be aware of that. Now, can you draw the line y equals 40? Yeah, rain's falling kind of hard on the roof. Can you draw the line y equals 40? And why would you draw the line y equals 40? It's because our original problem. Oh, just a second. The height of a ball on time t is this. Okay. So what do we have? We have the graph of this. And at what time is the height 40? Well, if y is the height, which it is, okay. Then you want y equals 40. And we'll see what we do with that. So what's the line y equals 40? Okay, now, if your artistic ability was making me pessimistic, which it wasn't, because you don't have to have it to do this, okay? I'm optimistic now because everybody did a good y equals 40 line about where it ought to be. Okay, let's see, should be right about here. Is that right? No, it's gotta be, you tell me up or down. There, okay, I can live with that. Here's y equals 40. Now, remember, this is 3 here, right? Can you estimate from your graph, it's not going to be a great estimate, can you estimate what these two t coordinates are? What's this and what's this? Okay, I should have made these points a little more prominent because not everybody apparently saw them, but this point and this point are where y equals 40. And we're on the graph of the function, right? Okay, so the y equals 40 line intersects the graph of negative 5t squared plus 30t plus 10. We want to project down to the x-axis, or the t-axis in this case, and then estimate what's t at this point and what's t at this point. What are your estimates? Okay. We have basically 3 estimates that people got. And it's kind of like in the ratio of 2 1s and a 1.5. If you average 2 1s with 1.5, you get 1.17. So I'm going to take an average of the estimates that I saw. And everybody's estimates were close to that. So one was a little higher, 2 of them were a little bit lower, right? And then here, our estimates were 4.5, 4, and 4. Okay. So we average those, we get 4.17. All right. Now, those are good estimates. And my estimate here might have been like over 5. My estimate here would have been a little over 1. Okay. But remember, my parabola wasn't completely symmetric. It was a little lopsided on this side. So everybody's parabola is a little lopsided. But if we average your results, we get this and this. Okay. So this tells us that t equals 1.17. How high is it? 40. At t equals 4.17, how high is it? 40. Because y is how high the thing is. T is the time. Okay. Now, we figured it out. We already solved the equation. We saw that the original equation is equal to 40. If t equals 1.26. How does that compare with 1.17? It's pretty darn close, isn't it? Okay. And t equals 4.74. Now, we're not quite as close, 4.17, 4.74, there's some discrepancy there. But we're talking about hand sketch graphs by people who will never make a living as parabola artists, including myself. Okay. So this picture represents our whole solution in everything we've done so far today. Okay. Comes down to this equation. Okay, so here's our equation. And here's a picture of the solution of that equation. We have our negative 5t squared plus 30t plus 10 here. There's a graph. And we have y equals 40. Here's a graph. Where they meet tells you the time when t equals 40. and another time when t equals 40. All right. Now, you understand how we graph this parabola, because that's in your next assignment. Okay. Graph the parabola by finding its vertex and its y-intercept. Okay. Now, at that point, you're not going to get an exact graph, but if you draw a pretty good parabola, you got to be able to draw them upside down. You got to be able to draw them right side up. The point is that the vertex lies on this line where x equals here. It's the vertex when x equals this. In this case, it's t, because we're using t. The other thing about the vertex is comes out of this. And if the graph is drawn with complete accuracy, the zeros are equal distances on two opposite sides of the vertex. Because this thing has to be symmetric. Anything on this side is going to happen on this side at equal distance. Didn't quite come out that way the way I drew my parabola. But that's the way it should be, okay? And that's the way it is in reality. If you draw a completely accurate parabola, which nobody can do. So here's a representation of the situation. And the equation is a representation of the situation. The equation that we solved here, well, we subtracted 40 from both sides and we solved this equation. So your procedure, if I give you the equation of a parabola, let me just ask you to quickly do this. Let's say we got y equals 2x minus 2x squared minus 4x plus 6. Okay. Where's the vertex? The y-intercept. Let's see if we can do that. We've only got about 3 minutes left, but let's see how much you can write down. Okay, we're out of time. But where's the vertex? Vertex is at x equals 1. That's how you find the vertex. Now I'm going to sketch a rough graph up here. So now I can say, okay, x equals 1. What's the y-intercept? Well, actually, now say, where is the vertex? Yeah, it's on the line x equals 1. Have 0. Okay. You get 2 plus 6 is 8 minus 4 is 4. So now I can say, okay, here's the vertex. Then so that's at y equals 6, so it's here. And now I can sketch a rough graph of that parabola. Another thing, the equation of the parabola. Y minus 6 equals 2 minus 2 times x minus 1 squared. 6 is this. And the 1 is this. If you expand this and multiply it out, you're going to get this. Solve for y, you're going to get this. Okay. It's called the vertex form. You'll read about that. And you're going to need that for your homework. You got questions? Email me anytime. Or find me. What greater than 0? Is it greater than 2? Was that it? Play on the domain 0, 2. Okay. Shorter. 0, 2.5. Okay, well, solve this. 2x absolute value of something's greater than 2 if two x minus 3 is greater than 2, or 2x minus 3 is less than negative 2. Okay. Because if the number is less than negative 2, that's like it's negative 3, negative 4, negative 5, the absolute value is going to be bigger than 2. Okay. And of course, if this quadrant is greater than 2, well, that's absolute value is going to be greater than 2. So we solve these two inequalities, we get 2x greater than 5. So that x is greater than 5 halves. So we just add 3 to both sides and then divide by 2. And then here we get 2x less than 1. X less than 1 half. Now, if your domain is from 0 to 2.5, it doesn't include 2.5, is that right?
Right.
Okay. Then any number greater than 5 halves is not in your domain. Okay. So this is not in the domain. And this part of this is in the domain, the part from 0 to 1 half. Okay. So there we have it. Then we can draw a picture of that. Solutions to the equation. 5 halves, which is 2.5. And 1 half is here. And we don't include the 1/2. And we don't include the 5/2. Okay, this is the solution to the equation on an unrestricted domain. But our domain is restricted to go from 0 to 5/2. So this orange domain is a restricted domain. The blue domain is our unrestricted solution. The blue arrows represent the unrestricted solution. And then the unrestricted solution, restricted to the domain, is just going to be here to here. With an open point here and a closed point here. That's a picture of it. And this is the logic of it. Okay, so we'll talk about the toolkit cubic function y equals x cubed. You should know the graph looks like this. You need to know the shades of these functions. And it's going to become really relevant now. And if you want to get that shade, you can write down a table quickly. And you get the points. Like one is here and one is here. When you come out to 2, you go all the way up here and you get 8. I made it a little too steep. -1's here. -2, -8, and 1/8. Okay, so you do a good job of the toolkit cubic function. If you haven't graphed that several times, graph it several times. You get home. Okay. This is your y equals x cubed. We can contrast that with your x squared function, which everybody could know looks much of this. Then we know the table. Okay. Here's the x-axis. Now, x goes to infinity if you just keep going this way. And x goes to negative infinity if you just keep going this way, right? Now, as x goes to infinity, what does y do? X goes to infinity here. What happens to the y value in this graph? Just point in the direction the y value goes. Keep increasing x, y keeps increasing, right? And it increases really fast. You know, if you just go from 1 to 2, it gets 8 times as big, right? Okay. Now, if you went out to 10 cubed, what's 10 cubed? Just show me with your fingers, just give me the digits. 5, 3, 2, 8, 9, whatever, okay? What is 10 cubed? 1,000. 1,000, okay? About half of you got that from 10. You said that, okay, so, where's 10,000? Where's 1,000? Okay, I say 10,000, 1,000, anyhow. 1,000, where's 1,000 in this graph? Can you jump that high? Yeah, Mac McClung can't jump that high. You know who he is, okay? Local guy won the slam dunk contest. This is pretty spectacular stuff. Okay, well, 10,000, that's 8, not 10,000, 1,000. 10 would be here. If that's half a foot, okay, then there'd be 100 of those in 1,000 to be 50 feet high. Okay, that's just if x equals 10. If x equals 100, you get 1,000,000, which is 1,000 times that high, 50,000 feet. Okay, that's kind of a maximum height that passenger jets can go. Usually don't go that high. I'm not sure what their maximum is, but somewhere around there. Now, we all know that there are balloons that go higher than that. Okay, and space starts a little ways beyond that. But the point is, 100 isn't that far out. That's one. That's like an inch. 100 inches is just a little over 8 feet. That's just over there. We go over there, now we got to go up 10 miles high. Okay. So that should convince us that y goes to infinity as x goes to infinity. Of course, y goes to infinity is going to be keep on this one, right? Not only that, it goes to infinity really pretty fast. Not nearly as fast as an exponential function, but that's large at the top. Okay. Now, as x goes to negative infinity, as we keep going along the x-axis, show me what happens to y. Just, slop it down on a graph. Just draw a quick sketch that shows me the essence of what happens to y as x goes to negative infinity. Okay, so, most people have an arrow going like this, analogous to what I did over here. And we could say that y approaches negative infinity as x approaches negative infinity. Okay. Now, take just again, we don't do anything meticulous. We don't have time for meticulousness. Okay, just slot down a graph of the x squared function and tell me what happens to y as x goes to infinity and what happens to y as x goes to negative infinity. Okay, what do we mean by x goes to infinity? It means this over here. As our x values keep going this way, what happens to our y values? They go up and they go up faster and faster, so they go to infinity. Okay. As x goes to negative infinity, y goes to infinity. So we have Okay, well, that's the beginning of what you need to know about polynomial functions. Okay. Y equals x to the fourth. What do you think happens as x goes to infinity? And what happens as x goes to negative infinity? Okay, well, to answer this question, it's not necessary if you think about what's really going on, but it doesn't hurt. Okay, I don't have room to even finish my table, but negative 2 to the fourth is 16. Negative 1 to the fourth is 1. Negative 1/2 to the 16 to the fourth is 1/16. 0 gives us 0. This gives us 1/16. And we're going to get 1 and we're going to get 16 again. And our stuff goes down way down low in the graph because it didn't start really small. Okay. Well, we got a big positive number here and a big positive number here. Okay. And the key is x to the fourth is going to grow faster than x cubed or x squared, right? Because you multiply by another x. If x is 2, you've already got 16 here, right? If x is 3, 3 to the fourth is 81. 10 to the fourth is 10,000. Okay, you can think about those numbers. Key is, this is a fourth power, they're all going to be positive, right? Your results, none of your results are going to be negative. You won't have a 0, but every other number, every other value is going to be positive. So y is going to go to plus infinity. So these numbers here, okay, here are your y values. If you continue the process here, always multiplying by, always taking the fourth power of the next bigger number, your numbers are going to approach infinity. And this side, they're going to approach negative infinity. So if you look at the table, if you go to bigger and bigger positive numbers, -3, -4, -5, you're just going to continue getting bigger and bigger. Okay. It's always going to be positive. And down here, it's always going to be positive. So maybe this helps. But, and you could always draw a graph. It's going to look a lot like this one, but it's going to be steeper and flatter. It's going to be steeper because you're going up to 16 rather than just 4 here. It's going to be up here somewhere. It's flatter because you're going down to 1/16 when x is a half. It's going to be much closer to the x-axis. You're going to have a graph that's flatter here and then takes off a lot faster. You want to understand those numbers to understand why that is. Okay. Numbers in our table, I think the numbers would be vertical. I don't have room to write a vertical table. But we understand that the numbers you would get in the y column would be these. Numbers go to infinity this way. Sorry, actually, well, that wrong. These are all negative, because you're doing a fifth power of a negative, right? And here. You go to plus infinity. So you want to be able to understand that in terms of the first several powers of x. And you pretty quickly conclude if you understand the numbers. And if you don't, make your tables and make them graph for x squared, x cubed, x to the fourth, and x to the fifth. And ask yourself what happens if we keep going. You want to understand the numbers. You want to understand why the graphs do what they do. But all your even powers are going to give you positive numbers when you go out this way. It's going to give you positive numbers when you go this way. All your odd powers, since you're multiplying three odd numbers to the negatives, you're going to get negative infinity as x goes this way and positive infinity if x goes that way. Okay. And for some reason, again, this is something people seem to have trouble understanding, which is why I spent this much time on it, because it should be pretty obvious. Problem is, again, you haven't thought about numbers enough because you've been allowed to use calculators too much. You haven't really had to think about the numbers. And of course, some people find it easier to think about numbers than others, and that can also be a factor. You want to think about numbers at least to the point where you can make these tables x squared, x cubed, x to the fourth, x to the fifth, and understand this behavior. Okay. Now, as it turns out, and I usually would tend to prove this in pre-calculus class, but can't seem to get to that level of abstraction in these classes. So you're going to have to kind of accept it. Let's say we got let's say we've got this. What happens as x goes to infinity? Well, as x goes to infinity, x is going to be positive after a while, right? There'll be bigger and bigger positive numbers as we approach infinity, and all these are going to give us positive, right? Okay. Let's make it a little less obvious. What if we do this? X to the fifth minus 100x to the fourth plus 1000x cubed. Okay. If you plug in 10 for x to the fifth is going to be 100,000. X to the fourth is going to be 10,000. 100x to the fourth is going to be 1,000,000. You're going to have 100,000 minus 1,000,000. That's going to make it negative, right? Now, maybe some of these make it positive, but you have this kind of battle between x to the fifth and negative 100 x to the fourth. If x is 100, or sorry, if x is 10, this is going to still be negative, right? Okay. Well, if x is 100, x to the fifth, well, 100 has 2 zeros, x to the fifth will have 10 zeros on it, right? X to the fourth will have 8 zeros. Multiplied by 100, you're going to have 10 zeros. So these two numbers are going to be equal if x equals 100. Okay. If x is any bigger than 100, this number is going to win. The positive is always going to win. And what happens is the highest power always wins. You let the numbers get big enough, the highest power always beats any other power, no matter how big the number is. Okay. So if X is bigger than 100, this one wins. If X was 1,000, okay, well, that would be quintillion. It'd be 1,000 trillions. Okay. And that would be, it'd be quadrillions, but okay. Yeah. This number would have a lot more zeros on it than this one. Okay. You got 3 zeros on X, you're going to get 15 zeros here. You're going to get 12 zeros from this one, 2 more from this one. You're going to have, this number is going to be 10 times as big as this one. Okay, well, you can ask yourself questions like that. The rule is that the highest power term always wins. You look and say that state a little bit differently. That's the idea. In the highest power, the term with the highest power is called your leading term. That doesn't matter if the highest power is over here someplace at the end of this thing. Usually we put it in decreasing powers. Okay. We write it in decreasing powers. Then if I wrote negative 100x to the 4th plus 1,000x cubed, then put my x to the 5th between that and the x squared. X to the 5th could still be the leading term. It's the term with the highest power. It's the highest power always wins. The reasoning here then is x goes to infinity, x to the 5th goes to infinity. And as x goes to negative infinity, x to the 5th goes to negative infinity. Okay. Well, now what I know is that this graph looks a lot like the graph of x to the 5th. And x to the 5th looks a lot like the graph of x cubed. Like I say, do those 5 graphs, or those 4 graphs. Except it's a lot steeper here and a lot flatter. I didn't do a very good job. I should keep curving around it. Okay. So this is y equals x to the 5th. The graph of this polynomial is going to be practically identical to the graph of x to the 5th until you get in close to 0. Up close to 0 depends on the scale of this graph. It's somewhere in the middle here. It can wiggle some in here, close to 0. And the graph might then end up looking something like this. So in the wiggly area here, it would look like this. You take a microscope and look in here. Now, of course, your scale, 1,000 might be here on the x-axis. Because we've got big numbers in there. Okay, so I just want you to get that perspective. The thing you understand is with the leading term, the term of the highest power, if you graph that, that's what the graph looks like until you get in close to zero. And the behavior of the graph is called the long run behavior. If we run a long ways along the x-axis, it's going to go to infinity. This thing's got to go to infinity. Run a long ways that way on the x-axis, it's going to go to negative infinity because it's an x to the fifth. Okay, well, there's more, but you'll get that in your book. That's a really important idea. Okay. Well, let me pause a second. Usually when you deal with a polynomial, you want it to be in factored form. Now, does this polynomial factor? Okay, can you factor? I don't know. But I can guarantee you it'd be pretty darn hard to factor. Okay. It would strain my abilities. And I know how to prove that not every fifth degree polynomial can be factored. Okay. And that's what fairly hardly can prove. You get an undergraduate school, or you high level undergraduate mathematics. High enough that there are a lot of schools that don't offer doctorates with master's degrees. They don't even do that in undergraduate school. Okay. But any institution with a strong mathematics department will do that in the junior senior. After you learn a bunch of calculus and advanced calculus and stuff. So I'm not going to ask you to learn how to prove that. Are you really? Okay. Now, so all I'm saying is that factoring can really be a conundrum. And another thing about factoring is that it's pretty useless. Because the things you get in the real world never factor. Okay. Still, factoring is useful for understanding the way polynomials behave. So for now, we're going to assume a polynomial is factored. So let's say we have y equals this. Okay. Now that polynomial is mostly factored. However, we can factor x squared minus 1. X squared minus 1 factors as x minus 1 times x plus 1. That's a special product that everybody should be familiar with. They probably aren't. Okay. Then we'll deal with that a little bit later. What's the y-intercept of the graph and what are the x-intercepts? Okay, now raise your hand if you think you got one of the intercepts. We're gonna have to go on. Anybody think they know either a y-intercept or an x-intercept? Okay. In order to find a y-intercept, x is 0. The y-intercept is the point of the y-axis is on the graph. On the y-axis, x is 0. So you got to know this. In x-intercept, y equals 0. Because on the x-axis, that's where the x-intercepts are. Y is 0. Okay. Okay, so y-intercept happens when x equals 0, so y equals what? Going to be 0 minus 3 times 0 squared plus 5 times 0 plus 12 times 0 minus 1 times 0 plus 1, using this form. Well, that's pretty easy. That's going to be negative 3 times 12 times negative 1 times 1. And you multiply that in your head, it's negative 36. Made myself enough. I'm sorry, positive 36. Two negatives in there. So it's always easy to find the y-intercept, unless you got a really weird function. Okay. And if I ask you for the y-intercept, of this polynomial, what would it be? Tell me if you're finished. Give just 40 seconds. Well, if x equals 0, what do you get? 20. This is 0, this is 0, this is 0, this is 0, you're left with 20. So if it's in this form, expanded form, it's really easy to find the 0, right? If it's in factor form, it's still easy to find the 0, it's just not quite as immediate because you got to do some multiplication. You just plug in 0 for x and you get y, and it's really easy to evaluate. Okay, so the x-intercept. Well, there's something you got to see. Can anybody give me a value, small fingers, a value of x that would make this thing 0? Okay, I can't see how many fingers you got there. Okay, 3. First one I see when I look at it. Okay, in this form or this form, if x is 3, what do you get? If x is 3, this gives you what? 0. Now this gives you 12, this gives you negative 1. What's 0 times 12 times negative 1? 0. As soon as one of these factors is 0, the whole thing is 0. Well, then there are 2 other values that are going to give me 0. Can you give me one of them? Look at these factors. Pretty obvious numbers will give you 0. Now, if you're looking at this thing, look somewhere else. Can't figure out where that's 0. As a matter of fact, it never is. You'd have to solve a quadratic equation. So, another number. Another number will give me 0. No takers? Well, if x is 1, that's going to be 0, isn't it? And if you got 1 0 in a product of numbers, the whole product is 0. You multiply anything by 0, you're going to get 0. And these are all multiplied together. and if x is -1, that one's going to be 0. So x-intercepts now I'm going to say this happens if x -3 is 0, or x squared plus 5x plus 12 equals 0. Or x -1 equals 0. Let's go on the board here. I think I am. Okay. Or x +1 equals 0. This, or this, or this, or this is 0. Okay. Well, x equals 3 equals 0. As a solution, x equals 3. This is never 0. That might be hard to read. That's why the quadratic formula. The discriminant, b squared minus 4ac that goes under the square root is going to be negative, and you can't do the square root of a negative. Square root of a negative is not a real number. Okay, so it's not a 0. And then x -1 equals 0. This equation you can solve. Don't really need to solve equations for this, this, and this. You can just see what the solution is. But if it was one of these was 17/5 x minus 28/7, okay? Then you'd have to write it out as an equation, but if it's a linear equation, you know you can solve it. So if a polynomial is completely factored, it's always easy to find its zeros. You just take every factor and set it equal to 0. The other thing is, polynomial always factors into linear terms. So you got a bunch of linear, like x -3, x -1, x +1, no squares, or quadratics. There's some mix of linears and quadratics, no matter how big the polynomial is. And every polynomial does factor. It's just that we can't factor. We can't factor. Okay, just get a random polynomial, modeling some business cycle or whatever. It's not going to factor. Might be close to one that factors. Maybe that'll be useful, but it's just not going to factor. It does factor. We won't be able to find its factors. Okay. So I said it doesn't factor, and that was incorrect. Every polynomial factors. It's just that we can't factor them. All right. Okay. So that tells you a lot about a polynomial. And you want it to be factored, and almost all the polynomials we deal with in this course will be factored. We'll do a little bit with factoring though. Okay, so we have a function of this form. It's a quadratic function. First thing maybe you want to understand about a quadratic function. It equals 0 if and only if x is one of the two values you get from this. Get one value for the plus, one value for the minus. This is a quadratic formula. Everybody's seen it. Everybody should know how to use it. What's the y-intercept? That. Okay, so the y-intercept is at y equals c. Because the y-intercept occurs when x equals 0, and if x equals 0, this is 0, and this is 0, and you're left with c. So whatever numbers are in here, that's going to be it. Okay, the graph is a parabola with its vertex in the line x equals negative b divided by 2a. And negative b divided by 2a is sitting right here within the quadratic formula smiling at you. Okay, that's not a separate formula you've got to memorize. Just recognize it in the quadratic formula. There's a logic to why that should be the vertex because of the symmetry. And because negative b is halfway between negative b plus this and negative b minus this. We'll talk more about that later. So simple idea that people seem to have trouble grasping. Okay, so we'll talk about it more. A little bit short on time right now. Okay. Okay. In the graph is a transformation to the y equals x squared graph. And the y equals x squared graph is symmetric about the y-axis, which goes through the vertex. So this graph will be symmetric about the line through the vertex, which is this line. It's pretty much, and that's pretty much what you need to know about the graph of the quadratic function. And I think I've got the back of one of these bills. And we can now look at graph of y equals minus 2 x squared plus 8x plus 12. Y equals 0. think I know I've known enough to think while I write, but nah. Okay. Had to write that kind of small, but it's just a quadratic formula. A equals -2, B equals 8, C equals 12. Something I have to assume you're familiar with, or can easily get familiar with just by reading about it. I've almost certainly done it before. Okay, 8 squared is 64. 4 times 2 is 8 times 12 is 96. Going to be positive because of 2 negatives. 96 and 64 is 160. And that's going to be 4 plus or minus 12.7 approximately over -4, which would be like -1 plus or minus 3.2, which would then give you -1 minus 3.2, -4.2, or -1 plus 3.2, 2.2. That works. Okay, so that's what the quadratic formula tells us. So we can actually start drawing a graph. Graph is going to go through the point 0, -4.2. And zero 2.2. Now the next thing is the vertex. Okay, something's terribly wrong. Oh, geez. What did I do? Okay, I totally screwed that up just by being careless. I wrote down my A number. Or should have written down my B number. I know better. But again, the whole thing of think while I write. Okay. That's -2. So that's going to be -5.2 or 1.2. So that changes my labeling a little bit. We get through this in a hurry. Not working. think it's right. Almost out of time. I don't have time to do a lot of thinking. And everything I was doing wasn't working. But now it's going to work. Okay, so your vertex is on the line x equals negative b over 2a, which is negative 8 over 2 times 2, which is negative 2. That's still not working. That's 2. That's 2 times negative 2, which is plus 2. So I'm pretending to make all these mistakes. So you'll be really careful when you put your numbers into these formulas, okay? Because you see what happens when you don't. And you're going to get even more confused than I'm getting, okay? I'm not confused. I know what has to be consistent, and none of it was. But now I think it is. So here's the line. X equals 2. And your vertex has to be on this line. Okay. Now your y-intercept is at y equals 12. That should be obvious. If you put in 0 for x, you get 12. And of course, that was part of what I told you to in the list of things. So we've used this, and we've used this, and we've used this. Now the graph is a transformation of the x squared graph, so it's symmetric about this line. One thing we haven't done is we haven't figured out exactly where on this vertical line the vertex is. But the graph is going to be a parabola. So the graph is going to have to be a parabola symmetric with this line here. It's going to have to look something like this. It's not well drawn. Okay. So the vertex is going to be here. I could estimate where that vertex is. If this is 12, that might be 20. Probably don't have a good estimate, but I can find out where the vertex is. Y coordinate of the vertex is y equals, let's call that f of 2. If this is an f of x function. In other words, we're going to plug in 2 for x. So that's negative 2 times 2 squared plus 8 times 2 plus 12. That's going to be negative 8. That's going to be 16 and 12. Oh man, I didn't know it was going to be 20. I just estimated that would be around 20, right? Turns out that I did one thing that actually turned out to be right. Okay, the vertex is at the point 220, and there's kind of everything you would want to know about this graph at the level of this course. Calculus, you do more with it. Okay. So it's a really important graph. It's a really important idea. If you've got to leave, we're 3 minutes over. I'll just say that the equation of this graph is going to be y minus 20 equals negative 2 times x minus 2. Okay. In other words, this is the y equals x squared graph. Reflected through the x-axis with And then after being reflected because of the negative sign, it's stretched by a factor of 2. And it's shifted 20 units in the vertical direction. And 2 units horizontal. So you start with the x-squared graph. You flip it upside down because you got a negative sign. And the -2 just goes here. It's where this -2 comes from here. Flip it upside down, stretch it out, so everything's twice as far from the x-axis. And then you just shift it over 2 units and up 20. Right there, you're shifting. And it kind of looks like you got this. You flip it upside down. You stretch it. Then you move it over here and move it up here. There's your graph. You'll read more about it